Okay, good morning, everybody. My name is Brett Robinson, like Janelle said. I'm president of Terra Building Group. We design and build LEED certified homes. So geothermal falls into the category under energy and atmosphere, under the subcategory of green power. You get 2 points for building a home with geothermal. My background with renewable energy is my first major in college was energy technology years ago. It was such a new technology that after the first year, there were only 15 people in the course. They dropped the course because there wasn't enough interest or money to keep it going. So I moved on into engineering. In '94, I moved back to the Pittsburgh area, started a high-end building company, and in '95, we started a geothermal community. My love before that was solar. As an 18-year-old, I wanted to move to Colorado, work in the solar industry, ride my bike, and ski. Once we did the geothermal project, I learned what a great technology it was and how underutilized it was. So that's a little bit about me.
Left and right, is it? Yeah.
Do your group do any multi-family houses?
We do. Yes. We have an urban solution series that is standalone for single, narrow, small lots, or it can be combined into multis. Good thing you're in the wings. So, what is geothermal? Geothermal energy is heat, which is the thermal part, and it's derived from the earth, so the geo part. There's a scientific definition from the Geothermal Resources Council. I won't read it for you. So in essence, geothermal is heat that's trapped in the earth. The earth is the heat source in the wintertime, and it's a heat sink in the summertime. There we go. Where is the geothermal energy? Really, it's just below the Earth's surface. About 10 feet below, geothermal energy is everywhere. The warmth is constant, and this warmth is renewable. The Earth has been generating heat for about 4.5 billion years. Here's a good temperature chart that shows the heat of the Earth. Each of these zones are used for different types of geothermal. And you'll see this chart quite a bit. So how do we utilize geothermal energy? Through geothermal power plants. They use high temperatures, and they're 1 to 2 miles deep. Through direct use, which is moderate temperatures, and it's also moderate depth. And through geothermal heat pumps, which is what we're going to stick with today and talk about the most. They are at lower temperatures and relatively shallow depths. And again, our Earth temperature chart. These are the power plant ranges. This is the direct use range. The geothermal range for our use is going to be way up in here. So it's pretty low temperature and it's pretty shallow. So geothermal power plants. The temperature that they use primarily is the 300 to 700 degree range. And they're typically 1 to 2 miles deep. The three basic types. There's a dry steam plant, which is more of a direct use. Flash steam plant, which is the most prevalent. Most power plants are in California. That's the #1 state. Second is Nevada. By far, those two states have the most right now. And there's the binary cycle power plant. Okay, you can see again back to the heat temperature. This is the flash power plant zone. Probably 1 to 2 mile area here. Your binary, and then your direct use. Then there's a zone in here that's the hybrid zone, which mixes binary and direct use. Currently, power plant production is third among renewables. It's behind hydroelectric and biomass, but it's ahead of solar and ahead of wind. Even though it's third, the U.S. is only using about 3% of its potential. So there's a lot of room for improvement. Yes?
That percentage of geothermal is third, is that across the country or?
That's nationally.
Okay.
It doesn't take into account international, which could be different percentages.
Different regions of the country, are there?
Again, most of the concentration for power plants is out west. The geothermal, the heat is much closer to the surface out there. You think of Yellowstone, you have your geysers. It's much more shallow, so you don't have the upfront capital costs for drilling and all the pipe work and all that you would out east. It's viable in this part of the country. It's just most of it is out west right now. Then there's direct use. Have any of you been to a resort where they have a naturally heated pool? That's direct use. And again, back to our temperature chart. I told you we'd see this a lot. You see the direct use zone. Medium depths, medium temperatures. Okay, so that's basically it for power plants. If you want to view more info on power plants, you can go to geothermal.org. Very good source of information. All right, now we're going to get into the meat of the presentation. It's the geothermal heat pumps. And I'll read this one for you. Geothermal heat pumps use the earth for groundwater as a heat source in the winter and a heat sink in the summer. The range of temperature is 40 to 70 degrees, and then this states up to 100 degrees. The geothermal heat pumps is a device which moves heat from one place to another. Transfers heat from the soil to the house in the winter, and from the house to the soil in the summer. Larry and David may have more information on this. They estimate 10 to 40,000 of these are built each year in the U.S. And back to our temperature chart. Geothermal heat pumps use heat way up in this range, usually 40 degree to 70 degree, and the depth is 10 to 300 feet. So it's very shallow, pretty relatively low temperatures. So how do we tap the Earth's energy? There are 3 subsystem components. The first one is called a loop, or the Earth connection subsystem. The next is the heat pump, and then the third part of the system is the distribution system, which is your ductwork. Okay, the loop. Loops are buried in the ground, either horizontally or vertically, and they're pretty close to the building that's going to be heated or cooled. The loop circulates a fluid, water if it's open loop. Most closed loops use a combination of water and antifreeze. How does the loop work? It absorbs heat from or relinquishes heat to the surrounding soil, depending on the season that we're in. The types of loops. We have an open loop system. This is well to well. So we have an underground aquifer. We have a production well that brings the cool water, or in wintertime would be heated water, into the building. Then you have a discharge well that gets rid of the water. This is the type of well geothermal well that was proposed for PNC. They wanted to use this system. What they found after analysis, they were unable to because the building sits on top of an eddy. So even though they had plenty of flow for the production well, because they were in an eddy, the discharge well would heat up that water in the eddy, and the efficiency would be reduced. So they had to scrap the plan for their geothermal use. Second type of open loop system is a well to water. So if you have a pond or a lake, you can have your production well out of the aquifer, and then your discharge well into the lake or pond. Advantages and disadvantages of an open loop system. Advantage is they cost less than a closed loop, and they are more efficient in transferring the heating or cooling. Some disadvantages are your aquifer. Sometimes the flow isn't high enough. Sometimes it has too high of a mineral content, or you have sand or sediment that are issues that have to be filtered out. Some areas you have a lot of regulation and permitting to overcome for an open loop, and there's more maintenance with your equipment with an open loop. You're sucking in sediment and sand that's filtered out. You have hard water issues. Okay, closed loop. Horizontal loop, if you have lots of property, you can dig trenching, usually 8 feet deep, put your polyethylene pipe in, so you get the proper length for the design of your system. Another type of closed loop is a directional drilled loop, similar to horizontal drilling for fracking. If you have a smaller piece of property, you can use a drill rig to drill horizontally, get your loops in that way. You have a pond or lake loop. If your pond is roughly 8 feet deep, the loop can be put into a pond. It sinks into the sediment. It's a constant temperature, similar to being underground. There's also hyperloops. So instead of 3 coils or more, it's a more condensed loop system for a smaller lake or pond. And then the deep well loop. This is probably the most common in our area. It's for smaller properties. You have one or multiple wells that are drilled to certain depths, depending on your system design, to use the loop most efficiently. This is the type of loops that I've used. And this is a home that we did with the deep well loop system. Can anybody tell where the loop would be in this front yard? Pretty tough to tell, because really that's the nice thing about the deep well loops is once they're done, you can't. This had 6 wells. 2 were here, 2 were here, 2 were here. 170 feet deep each well. Drill rig came in, drilled the 6 wells, put the loops in, filled the wells with bentonite. 2 days later, the excavator came out. In essence, dug a small pool around the loop down to about 8 feet. They're connected with a manifold, and then 2 pipes go into the house, one for production, one for discharge. Then it's buried. You can grow trees, shrubs, seed, warranted for 50 plus years. Closed loop benefits. The units inside last twice as long with a closed loop system in general. The reason is you're recirculating the same solution. You're not bringing in sediments, hard water, those types of things. You have less permitting and regulation. In some cases, you have none. Less maintenance. The loop is 50-plus year warranty. Disadvantage, it's slightly less efficient than an open loop. Since you're not pulling in the heat or cooling source directly, it's a transfer, you lose some efficiency. The second component was the heat pump subsystem. And I'll read this. For heating, a geothermal heat pump removes the heat from the fluid in the earth connection, concentrates it and then transfers it to the building. And then for the summer season, it's just reversed. Here's a good example of that. Since today we're in the heating mode. So the production well side takes heat from the earth, brings it into the geothermal heat pump, and then the heated air is through the distribution system. The cold air returns back through the geothermal heat pump, it's dumped into the ground where it picks up heat again, and it just cycles. Types of geothermal heat pumps, and David and Larry will hit on this more. I'll just briefly cover it. You have an all-in-one system that replaces your traditional gas furnace and your outside air conditioning unit. You have a split geothermal system where you have a less efficient or smaller geothermal system and some type of augmented heat system, such as natural gas or electric. It reduces that upfront cost of geothermal. Then you have hydronic. You can add on a hydronic system, heat your basement slab, your garage slab, your sidewalks, driveways, or your pool or spa. Some accessories, you have a hot water tank. In essence, you get free hot water in the summer, and it reduces your costs in the wintertime. Also, we talked about the hydronic heating add-on. And back to the hot water. Through the hot water tank, it's a de-superheater. Summertime, your return air in the house, it's hot. It's 90 degrees outside, it's hot in the house. It takes this hot air, before dumping it into the loop, it heats your hot water. So in essence, that's when you get your free hot water. And it dumps the excess back into the ground. Third component is your ductwork system. It's a traditional ductwork system, just like you would have in a normal gas and air conditioner or heating and cooling system. You're able to do multiple zones. You're able to do high MERV air infiltration or filtration systems, add humidifiers, use intelligent controls, and programmable thermostats.
What's MERV?
It's the filter number.
Gives you the efficiency of the filters.
It's minimum efficiency rating value. That's what the acronym stands for.
I know that's one of your favorite topics. Traditional systems versus geothermal. The EPA has stated that geothermal heating and cooling is the most energy efficient, environmentally clean, cost-effective space conditioning system available. It's in all 50 states, and on average, it's 45 to 60% more efficient than your standard heating and cooling. Here's a table. We've talked about some of these issues. Two that we didn't, there's no outdoor unit. Second, because of that, it's very quiet. In one of our topics about green building, there was a woman in the front row, lives in Mexican War Street district, very high-end houses. She said her and her neighbors cannot find one, cooling systems that are not noisy, and two that will use a balanced heat and cooling system for their homes. None of the neighbors, which we know that's available even in standard systems. But geothermal addresses those issues. There's no outside unit. It's very quiet. Other things we talked about, one is renewable, and then you get a 30% federal tax credit for installing a system. This talks about the tax credit. I'm not going to read it all. In essence, it lasts through December of 2016. Here's a cost example of a pretty high-end geothermal system. This is water furnace. There's 7 series, which is their top of the line, and they'll talk about that more. With the water heater attachments, all the ductwork that's zoned, a deep well loop, and a 3,500 square foot house. The one that we did was about $3,800, so it's pretty comparable. Average loop cost for this size home would be roughly $13,000, and that's going to vary. Your equipment and ductwork is about $15,000. 30% tax credit, so your initial investment is $19,600. And again, that's going to vary with the equipment you choose, so. So payback period based on that investment. Yes. As far as I know, yes, the 30%. Is that correct, Larry?
On a single home.
Or a single home?
Now, he moves, he does, buys another house and puts one in, and he
Can do it
file
again.
Absolutely.
Okay.
So this is operational tax credit.
So example calculation based on that investment. Geothermal investment 19.6 versus a comparable natural gas system. Equipment cost. So your difference is $4,600 that you would have out of pocket up front. Right now, an average gas bill based on the therm research I did would be roughly $90 a month or $1,080 a year. And that's a big variable. That can change depending on the type of house, etc. So using 45%, which would be the low end, your annual savings is $486. Your return, your payback period is 9.5 years, roughly. In '99, in this region was about 5 to 7 years, and in the Midwest is about 3 to 5. I feel the 9.5 is high. I think the return is probably more about 6 or 7. Again, you guys can hit on that a little more.
Is this affected by fracking at all?
No. Your fracking is down about 5,000 to 7,000 feet. These systems are down to about 300. So it's, you're a totally different usage area of the earth. Yes?
Are these systems only for forced air houses with ductwork, or could you retrofit an existing house that has a hot water heating system?
Yes, you can use a hydronic. So through the attachment, and again, these guys will probably talk more on that, you can connect it to that or run them through your floor joist or heat your slabs with it. So it can be done for that. Yes?
The numbers up there are really interesting for new build because you're essentially saying you're only using 4,600 extra compared to a natural gas system. But yeah, if you already have a house that's built like in Pittsburgh, you've got a functioning system, does it make monetary sense to switch over to geothermal, or is that a decision motivated more by?
I'll let David and Larry talk about that. They're going to be more knowledgeable about retrofits for existing homes. And I understand because the median age of our homes in Pittsburgh are 125 years old. So you have new construction and you have these very old homes. Second only to Philly in the country. So I understand. So maybe they can hit on that. Yes?
What assumptions did you make about the future increase in energy prices?
I left them pretty constant. Indicators are natural gas is going to stay pretty stable because of the oversupply. So I had to make some simple assumptions. And I know talking beforehand, my model's pretty simple. You can add tons of variables and change it.
That might account for the difference between calculated 9.47 years with the actual numbers of 5%.
Right. And like I said, I believe this is conservative. I think your payback will happen quicker. I really do. And the other assumption is you're using I've used a pretty high-end gas furnace and a high-end air conditioner. If you use a system that most production builders use, just meets code, just meets efficiency standards, I think your payback's going to be way quicker. Yes?
Are they the cooling impact in
Yes. Yes. Okay. And then the next slide, water furnace has a savings calculator that you can get online. You put in your variables, you can change parameters of it, and it can show you your savings. So it's more home specific, where my model is more general. Just to give you an overview, this is more home specific or project specific. Hey, come on. All right, geothermal for commercial uses. In general, it's the same systems that are used in residential capacity. Your differences are you're going to have larger equipment, you're going to have larger loops generally, and the biggest thing is your engineering and design is going to be different. Your ductwork. The home is basic, simple ductwork usually. Commercially, it's much more complex. Your zoning and controls are going to be more complex. And of course, you have more ventilation and fresh air requirements in a commercial structure than you do residentially. But in essence, it's the same design. Okay. I know Janelle can probably forward email to anybody that wants. These are active links that I use to get valuable information. Power plants, Geothermal Resources Council. If you're interested in how power is generated, very, very good source. I also use Water Furnace, David and Larry. And U.S. Department of Energy, they have a Geothermal Technologies office, which has its own website just about geothermal. That link's in the middle. Okay. So that's my portion. Any additional questions before I turn it over to David?
How come you didn't cite ASHRAE? ASHRAE's got a lot of information on geothermal, probably more than these guys, I would think.
Okay.
Just really, I've been through them. I think they probably beat all of them.
That's good to know. I'll have to check that site out.
Got a whole book on it. It's separate from the guide.
All right.
How many units did you install?
This development we did had 8 lots. So we put them over a period of years between 95 and about 2002. That's about the number of units that I've done.
In the experience, has there been maintenance issues or any?
The first house we did that I showed you, an engineer and his wife moved in. They moved from Flint, Michigan. He was in the auto industry, moved back. He understood the system. The biggest pushback I got, even in the 90s, which is only 15 years ago when this house was built, nobody knew what it was, and they were scared of it. Well, he understood it, being from engineering background. Natural gas bills in '99 were between $500 and $700 a month for a 3,800 square foot home. Gas prices were outrageous. He has gas dryer, he has gas logs in his fireplace, gas cooking. We put that in for him. The whole rest of the home is geothermal, hot water, electric geothermal. His bill in January for the whole house was $168. He's had no maintenance issues. He's done the standard maintenance yearly and no problems with the system. And the whole time he's been in the house. Any question?
I was going to ask, when you did several homes in the community,
Yes.
did they each get their own pump system, or did they share?
These were larger homes on larger lots, so they each had their own loop. There are cases where you can put multiple buildings on a single loop and save those costs. Yes?
You said you built 8 homes up until 2002. Was there a reason to stop using this system after that?
It's mainly owner preference. The preference, especially since gas prices are down, in my experience, is they would prefer to not have that outlay of cash and go with a natural gas system. So, that's why. It's not, I think this is a fantastic system, and I would use it in my home. If money were no issue, this is the system I would put in my house, for sure. But You know, if you look at the initial investment for this, they were $28,000 until you get your tax credit back. So it's a big outlay, and a lot of homeowners don't want to do that, no matter what you tell them. And these guys can talk a little more about that, how we can change that perception and make it more viable. Yes.
Is banks satisfied to lend for this sort of investment too? Do they give you any problems about getting mortgages?
The technology's not an issue. It's the appraisal of the home that is the issue.
Okay.
Ever since the housing crisis bubble, financial industry has gotten much more stringent. The appraisal guidelines have become very tight, and in some estimations, they're the other end. So you're getting low appraisals. So in some cases, it's tough to get the appraised value where you need to be when you're throwing on an extra 20 grand or even 10 grand sometimes.
Do these systems increase values? I mean, clearly they do.
From an appraisal perspective, I don't think that comes into account. I met with a realtor Saturday night, and she's very active in green. And that was two of the things that she didn't like about, one, the multi-list in Pittsburgh was it didn't differentiate LEED or green buildings. So if you're a homeowner, you get on the multi-list with your realtor, and you type in green or LEED, none of those homes come up. It just throws them into the same category. And two was the appraisal values. There's no way to efficiently right now differentiate between a green home and a traditional home, value-wise. Should it be more value? In my opinion, yes, for sure. Yes?
For closed-loop systems, is there any advantage of being close to a river or a major stream?
I don't think so, because a closed loop is taking the constant temperature of the earth. For example, that first home I showed, the earth temperature for that loop was 45 degrees.
Does help though, because you carry the heat away with the water.
Well, that's open loop.
No, I'm talking about closed loop. We do a lot of buildings, and we find that you do have some water flow that helps your.
So you found the transfer is better.
Because you have to think the earth is really a battery. It's not necessarily staying constant temperature. People might miss that. You can't overheat it.
True, which we talked about the PNC
so a little bit of water
situation.
flow is not a bad thing.
Okay, so you find it'll
Seems to even
discharge.
Right.
Okay. All right. Anything else? Yes.
Have you ever done anything with the mini splits? Have you made it at all?
I have not put in a mini split. I've used them in a commercial application in a computer room.
You do a whole house?
The booth beside me was Mitsubishi at the home show. So they had the mini splits. That was their display. We had this discussion about that. You can. The problem with the mini splits for a whole house is that they're a heat pump, and they're air-to-air heat pumps. So with the winters we had this winter, we had 15 below some nights. The efficiency, in essence, those systems stop working. Even the ones they have called hyperheat, they'll go down to about 5 below, and they're only about 50% efficient. So you get below that, they stop working. Mini splits, it's illegal to have, by code, it's illegal to have a supplemental heating system in them. There were fire issues years ago, so they abolished that. So you have no supplemental heat on a mini split. So unless you have baseboard heat or some other system to augment that, once you get below a certain point, you're done. And they said we had a lot of calls this winter. It's 15 below. Hey, it's cold in my house. Well, that's why.
I was looking at my house, it's a 3-story house, but it has hot water heat. They said you can't get on the radiators. It's wrong, I kind of ruled out, I was put air ducts in.
Right. Well, they were busy with people in your condition, or that your home's condition, not your condition. And that's the biggest thing they were looking for. People with family rooms that were cold, bedrooms that were cold. So they have a one-to-one system where you can put it on your wall, and they have one outdoor unit. And that sounds like it would work for your situation. Anything else? Okay, David, you ready? Come on up. Is it? Yeah, it sticks.
Brad, I turned this off.
Okay.
Oh, it's all right. I'll go ahead and I'll start here. Well, thanks for inviting us. My name is David Higgins. I'm a territory manager for Water Furnace. I cover northern Ohio and northwest Pennsylvania, actually just kind of north of Pittsburgh is where my area begins. Larry Brown is my co-worker. He's also a territory manager. He covers southern Ohio and southwest Pennsylvania, including the Pittsburgh area. We call on residential contractors in that area, and we help them to advance the cause through training and through marketing and different ads and bringing news about what equipment we have, new things we have on the horizon, and everything like that. So that's how we work, and we would like to thank you for inviting us here. And also, as you did with Brett, please feel free to ask questions as we go. Brett and I are going to have a little overlap on some of the things we talk about. Some of it maybe a little different perspective from ours, but if not, I'll just kind of zip by those a little quicker. So let's see if this works. Okay, thank you. And it's right? There we go, okay. Oops, okay. A couple of terms you might see, and you'll see this on the AHRI website if you go to look at efficiency values of equipment. I just kind of thought I would point this out. You'll see geothermal heat pump, abbreviated GHP, that's what we are. You'll see a ground source heat pump, we're called a ground source heat pump, GSHP. Ground coupled heat pump is another phrase that you'll see. You'll also see water source heat pump. Now when you see that's going to refer to boiler, cooling tower kind of applications where water is the supply for, it's not a direct connection to the earth. Geothermal energy, as Brett mentioned, it refers to shallow earth temperatures found anywhere using a mechanical device, geothermal heat pump, to transfer heat from the earth to the ground. So we're going to see some of these things here as we move along through this presentation. The overall concept is, and this question came up earlier, we can do what we are involved as water furnace manufacturer of this equipment. We're involved in what's called water to air. That's where we're converting a solution into air to distribute through a dwelling or a building as air, or will also be called, we have products that are water to water. They fall into the water to water category. That would be your radiant floors, your baseboard heat, your radiator heat, things like that. So a couple of concepts there. We connect that to the earth with a long, basically plastic, it's a polyethylene pipe that's buried beneath the earth's surface or placed in a pond. And these systems also, as mentioned, we can use open we can use well water. We can use aquifers under the earth. You know, Brett also mentioned solar energy. I think it's important to note that we are as solar as anybody, because it's the sun that heats up the ground around us that enables us to use the earth around our buildings for this energy. While air temperatures, which we'll see in the next slide here, air temperatures can fluctuate wildly. Living in Pittsburgh, I know you know that. They fluctuated a little bit this morning, didn't they? And but below the earth, just really a few feet below the earth, they're much more consistent. And heat pumps also move energy from one location to another. We are closer to your refrigerator as a geothermal heat pump than we are to your natural gas furnace or your propane furnace or something like that, because we're actually moving that. We're not generating heat. We're moving heat around. We're taking heat out of things and distributing it somewhere for comfort. And we do use the earth or well water to provide heating, cooling, and some hot water. We'll talk about that a little bit more. And again, we just move it. We do, in the process, eliminate the need for outdoor equipment that you associate with what we would call, I said we were water to air. The other guys are air to air. One of our competitors would be, air source heat pump would be an air to air. Geothermal literally means heat from the earth. The earth absorbs about 47% of the sun's rays that reach it. We also, I think this is interesting, we have, everybody thinks, you know, well, I'm not in geothermal country, or I don't. We have installations 27 miles inside the Arctic Circle, and we have installations 4 degrees from the equator. So it works everywhere. Again, a few feet below the earth, temperature is consistent. Ground temperatures are much milder. Here's something else. Water is a much better conductor of heat than air. If you've ever gotten a skillet really hot on your stove, and you know, how long would you have to wave that skillet around in the air to cool it off? But if you hit your cold water tap and hold that skillet under there, you know, it cools instantly. That water pulls that, it transfers that heat much more effectively. Cavemen knew this. Here's that chart I was talking about. Basically, this would be well water, which one of the nice things about the well water is the temperature is absolutely constant. The red line is 12 feet below the earth. The blue line is 5 feet below the earth, and you can see the deeper, the shallower you are, the more variation there is. This line right here is actually air temperature, so you can see how much more dramatic the changes in the air temperature are from, you know, up here to down here. And if you look at that blue line, that's only 5 feet below the earth. That's basically where we begin. We can put loops in 5 feet below the earth. That makes sense? Us versus them. This is outside. Basically, what that is, that's a heat pump. That's moving energy around. But what it's trying to do, if you think about this, I don't want to get too ahead of where we're going here, but that we take heat out of your house and we put it in the ground, which is pretty ready to accept it in the summertime. You know, when we're cooling your house, we're taking heat out. The ground's ready to pull it in. If you take that air source system, you're taking heat out of the house and you're delivering it outside, which works pretty good on a 75-degree low humidity type day. But the higher that humidity goes and the warmer that air temperature goes, the harder that air source unit has to work to force it out into the atmosphere to take it out of your house, and that costs considerably more to operate that. It's a lot easier. The ground is much more willing to accept it. So again, we move heat through a liquid medium and a closed loop, or through well water and an open loop. That liquid medium is not just water. We actually have an environmentally friendly freeze protection inside that closed loop. The reason for that is not so much as the risk of it freezing in the ground, but because we can get heat out of what, Larry, 28-degree water? We can actually get heat out of water that's only 28 degrees. So, and then when we return it by taking that heat out of it, it's even colder as it goes through the system. So that's the main reason for the freeze protection, if that makes sense. It's like food grade alcohol, basically. There's the chart. We saw something similar with Brett, but that just gives an example. This would be in the cooling operation, going down to the earth loop, and you can see how the ground on this chart changes the temperature of that medium, that solution flowing through. There's the same thing in heating operation or heat mode there. I kind of like this slide. I think it's to someone who hasn't seen one or hasn't actually installed one or something. It's a little bit of it's kind of mystifying what's actually there and what gets all this done. But basically, the number one there, you have a geothermal heat pump unit. In this case, it is what we call a package unit. It has a fan in it, so it actually blows the air. It has a refrigeration circuit in it. So that's the heat pump. We have an air filter that came up earlier. So we're different kind. You put electronic, electrostatic. We have a lot of options there. You have a loop pump. That actually is normally inside the house. Sometimes it's mounted right next to the unit. Sometimes it's in the garage. But that's actually the pump that's cycling the solution throughout the loop. You have the free hot water, number 4. We actually have we plumb normally. You don't have to do this, but it's an advantage if you're able to do it. We can plumb into an electric water heater, and we can supply about half of your hot water, the energy to heat your hot water, over a year's time. We like to say about half. I'll see anywhere from 47% to 52% on the reports that we put out. And that's a byproduct of compressor heat that otherwise we would just have to dissipate off somewhere. So when your system is working best in the summer, or when it's working most on really hot days in the summer, we're supplying heat for you. When it's doing its most work in the winter, when the compressor's working hardest, we're supplying hot water for you. And I mean, I noticed that in my house. I don't know if you noticed that in yours, Larry, but I actually can tell what the temperature is outside by how far I have to turn my shower on. There's a thermostat that controls it all. There's ductwork and an air and a water-to-air system, which is what this is. You got to have a distribution system in the building, and then there's a ground loop, and that's probably the most mystifying part because you only see that when it's going in. But basically, this pump is connected to the ground loop and pumps the water through there.
Do you use the variable speed pumps to those, or how do you your pumping?
We offer variable speed pumps. In most applications, they're not really necessary. However, I think Brett mentioned our new 7 series unit. Well, it's 2 years old now. It has a variable capacity compressor, which we'll talk about a little bit more there. And we do recommend a variable flow pumping system for that. So otherwise, you just, well, like if you're using open water, you just regulate the flow of water with just an orifice that regulates the amount of water flowing through there. So yeah, variable pumps are available. And there's probably a little bit of benefit on even a standard system. Not sure if that would offset the cost or not, but they're available.
Which is more efficient, water to air or water to water?
You know, it depends. I mean, if you look on paper, the water to air, the numbers, the performance numbers are higher, but it's not really a fair comparison, I would say, because of there are so many other benefits to water to water. For instance, a radiant floor. You know, if you think about it, an irradiant floor, if you have a 30-foot entryway or a 15-foot entryway, you only have to heat head high. You know, when you walk in and your feet hit that warm floor, your body feels really good. And I know I've seen a sort of a rash of this for horse barns, where people want to keep the horses somewhat warm, but they don't want to heat all the height and everything they have. And so that really doesn't measure into the efficiency, if that makes sense. That's a tough question to answer, but on paper the water to air is, but there are a lot of mitigating circumstances. So the ground loop then. Some applications we talked about: forced air heating and cooling. That's what we would consider a standard ductwork system in a house, where you're actually blowing the air throughout the house. That includes zoning, which our products are, or geothermal products are tremendous at. You know, if you want to have a separate, actually with our 7 series, you can control up to 6 zones in a house. You could have up to 6 different thermostats in your house, you know, if there's somebody just to keep everybody comfortable. Supplemental water heating, which would be like we talked about, domestic hot water, basically. And we can do that with other products. We have products where we can heat all of your water. So it's not just the byproduct of the compressor heat, but we actually can geothermally heat all of your domestic water. And then also dedicated water heating, which would be pool heating, spas, radiant floor, things like that. The question always comes up here, what about snow melt? Everybody always like, doesn't it sound like a great idea to go out and have it? Well, we can do it. You got to want it pretty badly, though, because it's not real cheap, but we can do it. Loop types, already mentioned, the closed loop system. We have a horizontal trench loop. You just dig a trench, normally 5 feet deep. You lay the pipe in there. You fuse it all together in a header. It's all fused together, so there's no possibility of leaks or anything like that, and then that's taken into the house. The horizontal boring, like the utility companies use to run wires and things like that underground. A great thing to the horizontal boring is it doesn't damage the landscape nearly as much as the trench loop. So a lot of times, like farms and things like that, where they don't care that much about how, and it's not forever, it's just until you got to pile the earth back up on it and let it settle back down gradually over at least a couple of seasons. So so that's the benefit to the horizontal bore is you don't get all the torn up, you know. Then we have vertical boring, which would be what we like to call these. I like to call them bores. They're bore holes that we put in the ground. They're not actually wells, because all we're doing is we're just boring a hole. Like for a house, it's normally a 4-inch bore. And then you put the pipe down in there, and then you put a grouting material in there to make sure the connection, the heat transfer, it's going to be touching the ground all the way around it. And so that would be, and then also we can use a pond. The pond, it's got to be a pond all the time, year round. You know, it can't be one that fills up in a certain time of year, and then when the drought hits, because that's a problem. It's got to be a pond all the time. It's got to have pretty good surface area. We like to see 8 to 12 feet deep. If it's a perfect pond, it's a great application. If it's suspect, probably should go with something different. And then the open loop, a little less common. We think 5% maybe.
At the most.
Yeah, and because of issues with supply and quality. So you got to have a lot of water, and it has to be good quality.
Is that water reasonable?
The water that comes out of I mean, it's not usable to it's perfectly safe. All we've done is change the temperature of it. So I mean, it's usable for whatever you want to do. However, some municipalities, things like that, there's still so much of a I don't know, I guess confusion of surrounding geothermal. Like I could tell you about a township that only in Cincinnati, Ohio, only lets you drill 50 feet deep. And so, you know, for somebody to get down there, they got to put, you know, 5 times more boreholes. So they got to have more property. And there's no reason at all that they shouldn't be allowed to go on a closed loop system as deep as they want.
They're concerned about water contamination. That's where water level, the aquifers and stuff are. And with the grouting and all that, we're sealing it back up, so it's a sealed hole. But it's a problem, and there's a lot of areas now that we can't even do open loops. I mean, they're just, you know, water's a pretty hot quality, you know, commodity, and
well, I'm even talking in this situation is actually a closed loop.
yeah.
But there's that.
We ran into trouble, we did an open loop, we had to make sure we put water back in and we took out. They wouldn't let us drain the aquifer.
Oh, really?
Yeah, we did it, but that's how you had to do it.
Yeah. And see, you can't put it back in the same place you took it out of.
You need injection wells.
Yeah, sure.
And you actually need more injection wells, you need production wells, but that's another story.
I mean, if you put it back in, you know, it's not because we're hurting it, but we can't, you know, we've compromised the temperature of it, so it's not going to work in the system. So you have to, another problem is you need someplace to get rid of it. I mean, it can't be here.
these days of the fiscal service where
No.
they make wetlands to catch the water that comes in, or to trickle down and feed the reservoir?
I have not seen that.
I don't know if it's a solution or not.
Yeah, yeah. There's just a shot of that would be a horizontal trench loop. At one time, that looked like a war zone. You know, I got to tell you, that's probably I tell my contractors, based on personal experience, you can't stress enough how bad it's going to look for a little while, because you kind of blow it up, you know. I remember my wife was, let's say, a little surprised by what ours looked like, but that's another story. But see how, you know, that's going to be all covered, landscaped, and grassy now. There's a system with vertical bores. That's what I put that on there. That's what would be at the very bottom of the vertical bore. You fuse those pipes together with that U-bend, and you just run that all the way down to the bottom of the borehole, and then you put this grouting solution. It's kind of like peanut butter. It looks like it's about the consistency, and you just grout it all the way up to the top. It's a great heat conductor. So that's also what you use in the directional bore or the horizontal bore. You hook those together, and then you pull that back through the borehole that you've just done. There's an example of a pond loop with a minimum, and I mean this is a minimum ½ acre and 8 feet deep. Again, we really like to see closer to 12. Actually, Water Furnace has 220 tons of heating and air conditioning for our building in a pond. Yeah, it's just, I mean, it's hard to call a pond. But done by experts who really know what they're doing. It's a great way to do it, but it has to be done right. The pipe, life expectancy of over 200 years. I mean, it's not gonna degrade once it's in the ground. Doesn't rust, rot, corrode. All connections are fused together. There's no fittings or anything like that. So it's really amazing stuff. That'd be an example of an open loop that would actually use an existing aquifer. You know, it works really well. It's a little more efficient when you look at the ratings of it because of that consistency of ground temperature. But it's just, and I mean, I know a lot of people who have it that are just elated by it. But boy, you never know when that water's going to just dry up, or if there's not enough of it, if it changes direction or something. In that case, you got to put a new loop in, or find a new aquifer. So that's some of the considerations we talked about already. 5 to 9 gallons per minute, a lot of water. And that's just like in a house, in a residence. It takes a lot of water to run one of these things. That's why it's nice when you've got it there just all enclosed in in your loop. Good quality, adequate place to discharge it, and the state and local codes are just, it's frustrating dealing with them. I'm sure you guys don't have any experience with any of that in here. Desuperheater, when the unit is heating or cooling most actively, it'll generate about 50% of your hot water. The rest of the water would be generated by your electric water heater, and we're just pumping our heat into there. So free hot water when the system is actively running. Benefits to geothermal, there are many. The energy savings all over the board, depends on what the type of fuel is. I remember a question about if you had an existing system, if it's viable to put geothermal in. I'm not really sure who that came from. Okay, it may be. If it's natural gas right now, you're going to have a really hard time seeing the return on investment. We'll be a little bit more efficient, but dollar for dollar, it would take you, a good amount of time. Somebody in my neighborhood just put one in just because they wanted it, and we have natural gas. I put one in because I work for Water Furnace. They put one in because they just wanted it. They knew how green it was, and that's just what they wanted. So if you have propane, absolutely. I mean, the other thing is we have to talk about if your system is broken and you have to put something else in anyhow, now you can kind of deduct that from the price of what the water furnace is going to cost, you know, so the geothermal system. So in most cases, there's a considerable return on investment. And also, I don't know, I don't speculate when I do my calculations on what energy is going to do, but I just have more faith in electricity being a little more consistent than I even do natural gas. I know as industry begins to ramp back up, they're going to use a lot more natural gas. I've also read articles, Larry, you probably read the same one I did. The drillers, the people who are going after the natural gas are frustrated because the prices are so low. They're not making the amount of money that they expect. It's not worth their effort. Their profits aren't coming in. So I expect we'll see natural gas supplies balance out. And then, of course, last winter we had an actual propane shortage. And I mean, they were limiting, I don't know if you had any experience with that, but they were limiting the amount of propane people could buy, and boy, they were paying through the nose for it.
Yeah, there were some parts of the country, they were paying $8 a gallon for LP.
I know here in Ohio, Governor Kasich actually waived some cross-state laws about truck drivers, how long they had to sleep and everything like that, because we were getting our supply then from the Midwest. And they were afraid people were going to run out of heat in a brutal winter. 30% tax credit, that's huge. Don't know what's going to happen in December 2016. We'll survive. We were around before there was a tax credit, and we think we're a viable enough deal in this in renewable energy. We compete as renewable energy with solar, and we compete with wind. But I'll tell you, folks, just to say it the way it is, the geothermal is the one that's being installed every day. You know, there's a wind farm over in my territory with what I think are somewhat unsightly. Excuse me if the windmills are your baby, but I think the landscape would look a lot nicer without them. It reminds me of War of the Worlds or something, like they're sprouting up out of the ground. And I heard it's costing 28 cents a kilowatt to generate electricity over there. So it's got to be subsidized, you know, and everybody's fascinated with it, but the one that's really getting the job done on a daily basis is the geothermal. You know, we don't make energy, we just use it a lot more efficiently. Our heat's a lot more even. We're not just kind of blasting enough hot air in your house until we satisfy the thermostat and then shut it off until it cools back down to where you need it again. It's a much more even heat. No outdoor unit. I know who appreciated that was my neighbor. Because you ever notice they put those things around, not by your patio, but by your neighbor's patio. And a lot less maintenance just based on the fact that they're inside. Long equipment life, actually ASHRAE, I heard that mentioned earlier, they rate the life expectancy of the geothermal heat pump 24.4 years. Anybody want to take a guess? The last I checked, what they rated a high efficiency natural gas furnace?
15.
9.7. Under 10 years, because they're taking so much heat out of that gas that the only thing left is condensate, and it's hard on their systems. They're finding that's hard on their systems. So, you know, when you put that into your return on investment, that's a pretty considerable chunk of change right there. No flames, you know, you can, if you go total electric, you can toss your CO monitor. You don't have to worry about any of that. I drive up in northwest Ohio where there's a lot of propane. Now I just get a kick out of what people do to hide their propane tanks. Someday I should put together an album, you know. There's one over there painted like a yellow submarine. And then there's trellises in front, but you unmistakably, you know, you see them. And you know right where they're at. And we are environmentally friendly. Typical homeowner, about 60 to 70% of your energy bill is to heat, cool, and provide hot water for your house. The rest is lighting and TVs and spas and things like that. Therefore, the biggest opportunity to cut down on your energy bill, since it's the biggest chunk of it, is to look at heating and cooling. Any questions so far? Or?
When you do like a package system for a home, is it
on the electric side, is it just a single circuit for your well pump, your furnace, everything? Is it a circuit for the pump, circuit for your furnace assembly?
Normally, it's a circuit for the pump and a circuit for the unit. And then also, we'll talk about this a little bit. I'm trying to think of the time to put it in here, but we have auxiliary heat. I think Brett talked a little bit about auxiliary heat. We recommend putting an auxiliary heat unit in your, wow, somebody watch my time, I'm not getting, we recommend putting auxiliary heat in. Here's why. We could do your home with no auxiliary heat. Our systems will do that. But you have to have more loop. You have to have a bigger unit, which is going to cost a little bit more energy to operate that, and it costs more to put in a larger loop. You got to pay for a higher capacity unit. So what we do is we have calculations. I'm not sure if we're going to be able to get to them today, but we have software that'll tell us how far, based on the loads of the building, they'll tell us how far our system will provide heating and cooling, or heating, I'll say heating in this case, how low the outside temperature can get before we have to bring in, and we call it supplemental heat. It's not emergency heat. It's not tragic heat. It's supplemental heat, and it just means the most economically efficient way to run that system is for the extreme coldest days of the year to have a little bit of backup heat to turn on to supplement the system.
And what is the heat?
What is the heat? It's resistance heat. It's a strip heater built inside the unit. Now our calculations, and Larry may agree or disagree, but we found the most economical way for us to put in a system is if that system in our area, speaking for where I'm from and where we're at here, if we can cover the heat load on that house down to about 17 degrees outside air temperature before we see, it's really, it's not that often that we get below 17 degrees. Throwing out last winter, which was a 57-year winter or something. But in a typical install, so yeah, last year somebody would have had to pay for more resistance heat. But the point is, they had it, they were comfortable, and hopefully next winter it's not going to be like that.
On average, you'll use about $60 to $70 in backup heat or assistance heat.
Yeah,
that's about it. And so we look for 15 to 17 degrees, what I like to call balance points.
Is that per season or per month?
For a year. Absolutely.
Yeah, per winter, basically.
It doesn't pay, and it's going to cost you to put in a unit and a loop an extra $3,000. You're never going to make it up. It's just not worth it.
Yeah, to put in a larger unit and more loop can get pretty expensive. So when we're talking about, and the phrase I like to use is return on investment. You're paying additional upfront to put this efficient system in your house, and now you're making an additional investment. Now you're looking to see how long it's going to take to get that return to you, and that's the most efficient way to do it.
Do you ever pay systems that use a solar hot water heater in addition to it all?
There are. I've known. I mean, that's unusual, but I mean that is usually where I don't know, somebody wants to build their house that way for a purpose, and they kind of do the research on it and everything. But most of our contractors, it's just they're looking for the least expensive way to put it in, but yeah, there's all different kinds of ways to supplement. I mean, there are off-grid homes and things like that. They're using. I mean, geothermal is about the only chance you have to go off the grid, so to speak.
So what is it, what do you use for the extra heating? What is there no?
It's just a bank of heaters. We have 15 kilowatt, 20 kilowatt, or 25 kilowatt, depending on the size of the unit, and it's mounted inside the system. It's just, yeah, you don't even see it. I prefer you don't even know when it's on. I kind of tell my dealers, because you can set the thermostat so you can know when it's on. But so many people panic, and they think there's something wrong with the system, and it's not. It's designed to be most effective to operate that way. Absolutely. Yes. Now, the subject of splits came up earlier. You can put a split in, which is basically what I told you was a package unit. Without the air distribution, there's no fan or anything in there. It's much shorter. You can put that in with a natural gas furnace. That way, our system will take your home down, heat your home down to 17 degrees, let's say. And then the gas furnace takes over at that point, the natural gas. And the gas furnace is also distributing the air year-round. I mean, essentially, we're an air conditioner. That's what our unit is. And it's just, this would be inside. We do make an outdoor one, but we don't sell many of them. But it's inside, and then the gas system would just serve as the distribution. Very, very efficient, especially with low natural gas. That way you have super air conditioning that nobody can touch, and you've got geothermal heating, and then you just have this, whatever your fossil fuel is to kick on as a supplement. Getting really more common. We're seeing, I can tell you dealers who say, well, I'll never put one of those in. I like the package units. When natural gas drops down to where it's at, they sort of change their marketing plans,
We're seeing it a lot in northern states where their utility rebates are only for splits because they have to shave their winter peaks. So they don't want that electric heat coming on at 17 degrees. They'd rather have the gas furnace coming on. So the utilities are pushing the splits now. And I think we're going to see that grow as winter peaking grows.
Larry.
My bad.
How's that? No, that's perfect timing. That's what I was going to say. How who really should be interested in geothermal, who should be pushing out there, the power companies, the power generators, the rural co-ops, things like that. Because when they buy their contract for the amount of energy that they buy in a given season, it's probably particularly summer, during the heating season, if they run out of energy and they have to go someplace to buy it, I've seen prices that they have to pay that are 4 or 5 times maybe what you and I pay for our, and it's only going to get worse, and it's called peak demand, and of course that's worse in the hottest days of the summer. The second worst time is in the coldest days of the winter. So we reduce that peak heating demand because we're using so much less energy on a 95-degree day to put that heat in the ground than it takes to put it into the air. So we reduce that need. We also have a product called IntelliStart, which reduces the voltage. It's technical, but to start that compressor up, we reduce that locked rotor amps, it's called, by as much as 70%. So the power companies just should be all over that. And
Tell the house that when the unit comes on and dims your lights, this will take care of it.
Just briefly here, this is the way geothermal is rated. We're rated in COP, which means the coefficient of performance. That's the category there, and it equals the ratio of heating and cooling provided by the heat pump. A geothermal, this is in heating mode. Air source heat pumps are rated by SEER. Well, you just talk about just a line. The air conditioning people really sold us a bill of goods when they stuck SEER out there because nobody even knows what it means. There's no humidity involved. I think it came from Philadelphia, as a matter of fact. But we're rated in COP, the coefficient of performance. That basically, in heating mode, that means whatever amount of money you spend per dollar. Let's say if you spend $1 down here on an electric furnace, if you have an electric furnace, and you spend $1 for heat, you get $1 back. You get $1 worth of heat back. Now that sounds perfect. If you look at a fossil fuel furnace, if you talk about it, even a 97% efficient gas furnace, for every $1 you spend, you get 97 cents back in heat. That really sounds good too. Sounds almost perfect. If you look at the geothermal, for every $1 you spend, you get as much as $5.10 back in heat, depending on the efficiency of that unit, because we're using so much of it from the earth. Does that make sense? One of these days, I hope, everything's going to be rated on COP, and that will pretty much wipe out our need for any tax credit or anything like that, because that'll be real numbers where you can really compare it to what you're about to spend. By contrast, in cooling, we're rated on, geothermal heat pumps are rated on the energy efficiency rating. This is where the air source heat pumps are rated on SEER, and they have 22 SEER or whatever that is, and people think, well, or I don't know how high they go, but if we have something that's maybe rated at 30 SEER, you think, well, it's not that far. If you look at it in EER, both of them, it looks a lot different. Just these numbers vary so much but this is just a rough estimate of stuff I see fairly regularly, and the big one here is if you compare it, to propane. as opposed to geothermal. You know, even high efficiency propane, that's where you start to see your 70%.
We don't have much propane.
Yeah, yeah, I know there's a little bit more north of the state, but. So typically at a new home, you can have positive cash flow from day one. That's why the beauty of our system is put in, because the added cost in adding that equipment to the mortgage is offset by the reduced operating costs. In other words, if it costs $30 more to add a system onto your build, and you, from day one, your heating and air conditioning bill is $50 cheaper, you've got $20 more in your pocket per month. That's why for new homes, it's just like, I mean, you know, where it's easier to put the loop in and everything. I mean, it's just almost a lock, you know. Existing homes, Brett talked a lot about the return on the investment. It's not uncommon at all with the tax credit to see it in 3 years, 3 to 5 years. It's very common. The future, a little bit about what we've got going on. We touched on our variable capacity compressor, which we call our 7 series. And that is the heart of our line is our 5 series. That's a 2-stage compressor. It operates about 80% of the time in low capacity, which is very cost effective, very efficient. It can do 80% of the heating and cooling in your house a year on low capacity. And then it kicks up on colder days, it kicks up into high capacity to satisfy the thermostat, and it floats back down. Variable capacity compressor technology is entirely different because it just runs at whatever stage it needs to satisfy the house. It just runs just enough to keep the house comfortable. It runs, a variable capacity runs it's designed to run 6,000 hours a year. Our 2-stage is designed to run about 2,500 hours a year. So it kicks off. But this one, the 7 series, runs about all the time. So it's dehumidifying all the time. It's filtering the air in the home all the time, and it's keeping the temperature just really comfortable all the time. So we're the first variable capacity compressor geothermal unit on the market, and we've got some other plans for that.
What kind of upcharges are you seeing on a system like that over your standard?
You know, that would be up to the contractor, but how much more would the variable, couple, 1,500, 1,800 maybe?
Anywhere from 15 to 2,000.
Yeah, somewhere in there. Again, the tax credit cuts into that, you know. We're also, any more questions about the 7 series, about the variable capacity compressor technology?
Yeah, is it digital, or is it actually variable slope?
It is actually speed. It has 12 speeds in heating and 10 speeds in cooling. So it's digital. Right.
We're also experimenting, and well, I guess we're beyond that because I think we're ready to put something on the market later this year with vaporized refrigerant technology. Somebody talked about baseboard or radiant heat, that you maybe were told you couldn't get geothermal. I would kind of be curious if a water furnace dealer told you that, because we already have a high temp unit right now that is made to compete with boilers, made to put us, it doesn't work on everything, but with this variable vaporized refrigerant technology, we're going to be able to generate like 20-degree hotter water than we are right now, and we're still using the same refrigerant that we use. So I expect to see that really take off.
You need to run through a hot water radiator and be comparable.
I can't stand and say across the board, but you certainly would. I mean, you know, it depends on, like everything else, where the radiators are located, how efficient they are, but it puts us in that mark.
And how much surface area you have.
Yeah, there's still issues.
But it'll produce up to 150 degree water, drinking water temperature now. So, in a lot of applications, it's going to work.
And the last two quick here, we have a home energy management system coming out that will enable you to control your house, your temperature, your zones, everything you want remotely via the internet. And your contractor will be able to diagnose your system. He'll be able to run checks and things like that from his. I think that's September 1st. And then GEO is the Geothermal Exchange Organization, and they are working frantically to try to make sure that our tax credits continue. 99% of people who have geothermal say they'd buy it again. We're really starting to see in the market where now they're starting to break down 30 years ago, that were put in 30 years, 25 years ago, and they immediately, now it's the same as a normal system, because you already got your loop in, you got the hard part out of it.